All right. Hi, everyone. This is Group 7 presenting unsustainable practices and pollution in the Amazon River region.
I'm Melody, and so these are the Amazon River specifications. There are about 55 million US gallons a second. The length is 4,086 miles, and the maximum width is about 62 miles. Discharge accounts for about 20% of the total water carried to the oceans by the river. Specifications continued. There are 8 countries that are part of the river basin, and there are a population within the area is about 28 million, and the types of water systems within the area include rivers and streams, wetland forests, meadows and marshes, lakes, Andean peatlands and meadows, and tidal wetlands. In these 6 pictures, you can see that there is a wide variety of different ecosystems that are held within the region. They look completely different, and they house different types of species of animals.
The 3 main activities that put the river at risk is agriculture, mining, and deforestation. With deforestation, it allows more runoff to be put into the river. And with farms being put up next to the river for livestock and crop purposes, it allows those nutrients put onto the farms to be swept into the river as well, which leads to major changes in the pH of the river, which causes it to be more acidic, which is not good for animal life. With all these pH changes in the river, it also changes the soil chemistry as well, which can cause plants and animals to die. Another little fun fact about the Amazon River is that it accounts for over 20% of the ocean's fresh water supply. It's been found that fish that are carnivorous have higher concentrations of mercury in their system as well due to these changes in their environment.
Hello, everyone. My name is Anthony. I'm going to be talking a little bit about little side influence on the pollution in the Amazon River region. And a lot of that has to come from illegal gold mining, which has mainly taken place in the 90s and 80s. But I mean, the effects are still being felt today with a lot of recent tests. So one of the main techniques that they use, and one of the most common techniques in general with gold mining through a river system, is placer mining. So that's done close in proximity to water sources. So obviously in this instance, it'd be the Amazon or any of its tributaries. So the process involves clearing out vegetation and basically overturning the top layers of soil so that you have access to the deeper, richer materials that may house the gold. Those processes are called descanaping and destape. And then, so soil containing gold is sluiced with a gravimetric sluice in the river water to remove a large portion of the lighter sediment and debris. Then what they do with that final step is they add mercury to those heavier solutions and then basically incinerate that and then cool it off with the river water again. And a lot of that excess mercury ends up getting into the river system and then the water and then flowing downstream into different areas, polluting all kinds of different fish and wildlife in the area. So this picture right here is an example of a gravimetric sluice that they use in the Amazon. So I don't know if you guys can recall from class whenever we talked about the gold rush in California, they were using a similar descaping technique where you basically funnel the water out and use that and gravity to basically filter out some of the lighter sediments on top. And then it should leave some of your heavier rocks and your gold trapped inside of the sluice. So not only are there high traces of mercury being found in the water samples, but a lot of indigenous contaminants are also being found in this process. So these are like your deep internal sediments. You're finding things such as arsenic, lead, manganese, and iron also being found in trace materials downstream from these areas. These have some of their own neurotoxic effects to not only humans, but other living creatures. A lot of the designated clearings for mining, they bring up loose soil mounds, so these are easily eroded away. This is usually where those heavier sediments are found on the banks, and then because it rains so often in the Amazon region and flooding is also very common, a lot of these loose sediments are easily sucked into the river system. As mentioned previously, traces of mercury have been found in many aquatic species. Mainly the carnivorous fish, such as piranhas, have been found to contain very high traces. And a lot of this mercury is just finding its way through the metabolic system of all the creatures in and living around the rainforest region. As we'll probably discuss later, you will hear some about the people that are consuming the fish readily are actually also showing traces of mercury in their hair.
Hey, this is Zehao, and I'm gonna introduce the economic impact. So around 90% of the mining operation are actually illicit and not government regulated. And none of these activities actually help the developing governments of the Amazon. Actually, none of the revenue is recorded in the GDP, and it is not taxed to the benefit of civilians. Unfortunately for the miner in Peru, the profit from mining is greater than any profit earned in the legal economy. The massive quantity of the waste is far greater than the economic yield from extracting gold. Continue with the economic impacts. While increasing personal income significantly from 1991 to 2000, the increase of prevalence of the industrial production and the agricultural practices are not benefiting in real terms. HDIM gauging income, schooling, childhood stability, habitation, like all of these things that actually affect the civilian living in the area, only benefiting minimally. Deforestation has shown minimal positive growth in the economy or ag business. From 2007 to 2016, average annual growth value derived from new deforestation in agriculture only reached 141 million in value, represents only 0.013% of the GDP on average for the 2007 to 2016 time span in Brazil.
Some social impacts that occur with this is that up to 6 million people are at risk of heightened mercury exposure due to water contamination from the mining, as we stated previously. Some villages have been tested and revealed that high levels of mercury were found in their hair. This is coming from a local reliance on fish and other riparian species for food. Mercury is a neurotoxin affecting sensory perception and sight failure. Some solutions that we have came up with is our government activism, investment in portable water testing devices, river catchment systems, dam removal, and create more nationally enforced protection areas.
So talking a little bit about the water testing devices that were, I think is a viable solution in terms of addressing communities in need as quickly as possible. Looking at how they detect, the Amazon region obviously severely lacks the appropriate water testing in a lot of the regions. So this is actually an electrochemical measuring device that's been discussed in Bernalte and his associates actually this year. And through attempting to garner some slight samples, using basic beakers and all of that, they can actually conduct rapid on-site detections of certain materials, such as copper, lead, and mercury in the water samples. And this is usually gone through with a computer and through smartphone. So you really don't need any large on-site devices. Once it's hooked up to a Palm Send 3, then you could basically just hook the USB up to that in the laptop, and then it also connects through an app on your phone that then delivers the results. These measuring devices, as I mentioned before, are hooked in their small battery handheld devices, and the results come up instantaneously, so you don't have to wait for any of the results to come in. So it's delivering that on-time record that you need for when you're dealing with polluted communities and water. So getting on to the government activism, through some of the literature that I've reviewed, I found that a good example actually comes from the state of Parma in Para in Brazil. So a lot of what they've done is combine local trade unions, and they've been associated with NGOs, non-governmental organizations, and basically putting the money and education towards involving the scientific purposes of activism and how the importance of that can affect local economies. One good example that they've actually seen come out of this is the pilot program for protection in Brazil's tropical services. So the tropical services would include anything from basically feeding people to tourism or anything involving direct local economy that doesn't involve kind of any industrial or agricultural waste. And they've actually found success in channeling a lot of funds to this part of the Amazon through the environmental bureaucracy that they developed. Most of this, another part that should be mentioned in government activism is making a change. I know that some of the studies that I've read before pointed to a lot of people in Brazil being for environmental protection procedures, but I do realize that there's a lot of people in the country, as mentioned before, with the poor HDI index, that we need more education in this area. So we need to increase education and awareness for the health of the ecosystem. Really, we need to have more awareness for what's actually being discovered inside of the Amazon River. You know, those studies concerning the mercury in the hair and the basic health effects that are being affected on local tribes need to be addressed and more actively pursued. And we need to engage in cooperative politics. So that means, you know, dialogues, negotiations, alliances and partnerships such as with NGOs, and just establishing partnerships and networks with the funds to allocate towards government activism that can really make a difference in the region.
Hi, everyone. This is Chance. I want to talk about river catchments. So currently, most conservation efforts, I would say, is based solely on terrestrial ecosystems and identifying areas that are unique or are based so strictly upon all the things that are on the surface, like the trees or the species in the area. So certain conservation units are only looking at what's going on above the you know, out of the water and out of the soil. And the idea to solve some of this water issues is to switch the terrestrial based conservation system to more of a river catchment based conservation system, which is shown to, you know, minimize the effects of anthropogenic disturbances such as pollution, deforestation, over harvesting. And what they find is that this is a better estimate of these critical areas. And the goal of this is to improve hydrological connectivity to all the freshwater ecosystems. And by doing this and focusing on not just you know, the surface runoff and the things that are going into the stream, but also like through the movements through the soils that contribute to the tributaries, and look at, you know, what's contributing there and improving those types of connections to also disperse the water more evenly and benefiting the vegetation and the different parts of the ecology to improve the system overall. And doing so will, and accounting for the things flowing into the soil, which also acts as a filter, and improving these catchments will also improve the local residents' access to clean water, which they depend on, and improve aquatic species health. And it's going to reduce these flood pulses that stir up riverbed sediment, which form floodplains up to 10 kilometers, which is pretty wide and impactful. So the second thing we were finding as a good solution was dams. So as we've talked about, dams have their own pros and cons. And there's around 150 dams currently in the Amazon basin, and there's even more that are being planned to be implemented in the future. And they use this as like a cheaper method of obtaining energy. And this particular region, 70% of their energy comes from these hydro dams. So it's important, but what these dams are doing is they're pressuring biodiversity by blocking the fish's pathways to the streams and the tributaries that can affect their spawning. So, and it also reduces the flow of the nutrients that comes down from the headwaters of the Amazon. And those are vital for the vegetation as well as the water comes down and the aquatic species and it affects the water chemistry from the minerals in the rock. And if you put a dam there, it's not getting down the river effectively. And also dams being in place are displacing indigenous people. So that's a social concern. So the idea of removing dams that aren't being efficient or useful, or ceasing construction of new dams and moving to a more efficient or more practical alternative energy strategies, such as like wind power. And implementing these effectively can bring back the Amazon to a more natural flow, more natural state of things, protecting the natural species and that exists there already. And it would also solve the domestic disputes by, not having people being displaced, and bringing more stability to the region. And it will reduce the impacts, as we had talked about, on the environment. And the last statement here is just to show that, other people are switching away from these dam powers and they're finding more efficient means. In the US, we're taking over 60 dams per year down. And so we're finding a way to do this more efficiently. And this right here, the protected areas. So there are protected areas in the Amazon, and they're shown here on the map in the dark green. And there's also these sustainable use areas that people have designated. And this is more the terrestrial conservation efforts have been based on these areas. And you can see in the red here all the deforestation that's been going on. But I'd like to point out that, if you look at the river itself, which is in blue there, it doesn't seem like these are the areas that are being protected directly right next to these, as well as various tributaries throughout. And the water chemistry is important to this area, and implementing more protected areas in these places next to the stream or the stream itself can improve the species health, reduce runoff, and also, there's about 70 million hectares of land that's not being currently used for anything, and they can be made for conservation units, which also have the potential to prevent 8 gigatons of carbon emissions by 2050. And this is to maintain the local climate, and as we're all dealing with the climate change, and keeping it to a relative minimum in these areas, and improving the hydrological and rainfall patterns. And here is a list of our references. Thank you.